Welcome back to Stewart Science. Today we're talking about the net force, which is a pretty simple concept, but it can get kind of tricky when we actually start throwing numbers in. So the net force isn't an individual force, but it's a combination of all the forces acting on an object. It's the sum of all the forces. And so to find this, you just add them up. If I wanted to put this in an equation, I would say like F1 plus F2 plus F3 plus however many forces I have equals the net force. And so the net force is just the combination of all the forces acting on an object. It's that simple. Now, let me show you how this works out. Remember, when we talk about forces, they're what's called a vector. So we have the positive direction, which is usually to the right and down and up. And we have the negative direction, which is usually to the left and down. So whichever way our force is acting, we need to consider that before we add it in. And so let me just give you some really simple examples. Let's say I have 3 Newton force and 5 Newton force. I don't know if both those things are acting on my object, what's the net force? Well, in this case, just take 3 plus 5. F1 plus F2 equals F net. So I have two forces. F1 is 3, F2 is 5. Add them together, bada bing, bada boom. 8 newtons is our answer. Don't think too hard. Now, what if we add in another force to this that maybe was negative 10 newtons? Now, all we have to do still is just keep adding them up. You have 3 plus 5 plus, and this one is a negative 10 because it's pointed to the left. It's that easy. And so we take 3 plus 5 plus negative 10, and we get negative 2 newtons. Ta-da! This also works up and down. If I have a, let's say, 20 Newton force and negative 35 Newton force, I still just add them. 20 plus negative 35 equals same equation, F1 plus F2. Just happens that F2 is negative. So our answer here is negative 15 newtons. Ta-da! It's that easy. Now the only way I can make this a little tiny bit more challenging is, as always, I can throw in a little bit of algebra. Let me give you one final example. As always, the only other thing I could do to make this a little tiny bit trickier is to add some algebra to that. Now remember, our equation is very simple. F1 plus F2 plus any other F's that we have equals F net. So let's say I give you F net. Let's say I told you that you have a net force of 2,500 newtons. And let's say I told you that one of the other forces of these two is 3,200. What's F2? This is very simple. Just do a little bit of algebra to get F2 by itself. Subtract 3,200 from both sides. And that means that F2 has to be negative 700 newtons. Let me do that another example with a little bit less explanation. Let's say that net force is 38 and one piece is and one piece is 50. Really, the question I'm asking is, what do I have to add to 50 to get 38? Because my equation looks like this: F1 plus F2 equals F net. I told you you end up with 38, and you started with 50. So the question is, how'd you get there? The only thing you can add to 50 to get 38 is minus 12. So this is one of those things that you could definitely overthink, but it's also one of the things that you could definitely underthink as well. So just keep that idea in your head. Net force isn't an individual, it's the overall. When you add them all together, what do you get? And so if I give you a net force and a piece, you just have to use this equation and a little tiny bit of algebra. Take the net force minus the piece, and you get your other piece. Otherwise, just add to get the net force. It's very simple. As always, it's Mr. Stewart. Keep learning, no matter what.